Good evening. Please get comfortable and settle in because tonight, we're setting sail on a different kind of voyage. Not across the bright surface of the sea, where the wind fills the sails and gulls circle overhead, but beneath it. Far below the rolling waves lies a quieter world, one where sunlight fades into soft shades of blue, sounds become distant murmurs, and history unfolds in near silence. Our journey will take us through more than 4 centuries of invention, ambition, exploration, and quiet determination as we trace the remarkable history of submarines. Along the way, we'll meet inventors who dared to imagine the impossible, engineers who patiently solved one problem after another, and sailors who spent weeks or even months living beneath the ocean's surface. We'll discover curious wooden contraptions powered by human hands, early experimental vessels that barely managed to dive, elegant machines driven by diesel engines, and enormous nuclear submarines capable of circling the globe without ever needing to surface. But this is not a story of battles alone. While submarines have certainly played important roles in history, tonight our focus is something gentler. We'll spend just as much time exploring the people inside these remarkable vessels, the ingenious engineering that keeps them afloat, or rather, carefully suspended beneath the waves, and the enduring human fascination with reaching places that once seemed forever beyond our grasp. Because, if you think about it, the ocean has always inspired wonder. Long before anyone built the first submarine, people gazed out across endless stretches of water and wondered what secrets lay beneath. Ancient sailors crossed seas without ever knowing what existed below their ships. Fishermen hauled up strange creatures from unseen depths. Divers held their breath for precious moments before returning to the surface with pearls, coral, or lost treasures. Beneath them stretched an enormous world that remained almost completely unexplored. It is perhaps only natural that someone eventually asked a simple question. What if we didn't have to return to the surface? It sounds obvious today, in an age of advanced technology, but for much of history the idea seemed almost magical. Water is heavy, relentless, and unforgiving. It presses from every direction. It extinguishes fires, drowns engines, and leaves humans with only a few precious minutes of breath. Building a machine that could survive beneath the sea required solving countless problems that no one had ever encountered before. How could fresh air be carried below the waves? How could a vessel sink without sinking forever? How could people see where they were going when surrounded by darkness? And perhaps most importantly, how could they safely return to the surface again? These questions occupied inventors for generations. Some produced clever sketches that never left the drawing board. Others built curious wooden vessels that floated awkwardly before leaking almost immediately. A few courageous volunteers climbed inside these experimental machines anyway, trusting little more than craftsmanship, optimism, and perhaps a touch of stubbornness. Progress came slowly. Sometimes decades passed between important breakthroughs. One invention solved a single problem only to reveal 3 more waiting beneath it. Better materials led to stronger hulls. Improved pumps made deeper dives possible. New engines extended underwater journeys. Batteries, periscopes, sonar, radio communication, and eventually nuclear power each transformed what submarines could accomplish. Like the steady rhythm of the tides, advancement rarely happened all at once. Instead, it arrived little by little, each generation building quietly upon the work of those who came before. As we travel through this history together, you'll notice another recurring theme. The sea itself never changed. The same oceans that challenged 17th-century inventors continue to surround modern submarines today. The Atlantic still rolls with long grey swells. The Pacific remains vast beyond imagination. Arctic ice still drifts silently above hidden waters. The pressure grows greater the deeper one descends, just as it always has. In many ways, submarines are remarkable not because they conquered the ocean, but because they learned to coexist with it. They became guests in a world never intended for human habitation, borrowing just enough technology to visit before quietly returning home. We'll also pause from time to time to appreciate the ordinary moments of life beneath the sea. The routines of sailors sharing tiny sleeping quarters. The careful preparation of meals in impossibly small kitchens. The quiet hum of machinery that never truly stops. The steady ticking of clocks in a place where sunrise and sunset no longer mark the passing of the day. These everyday details often tell us just as much about history as the famous milestones. Throughout our journey, imagine yourself not standing on a dock watching events unfold, but traveling alongside them. Picture the smell of polished wood inside an early hand-powered submarine. Hear the gentle splash of oars moving beneath the Thames River centuries ago. Feel the cool steel walls of a 20th-century vessel as it slips silently below the waves. Watch beams of light disappear overhead as the water grows deeper and quieter with every passing moment. There is something strangely peaceful about the underwater world. Above the surface, storms may rage, winds may howl, and ships may hurry toward distant ports. But below, everything moves more slowly. Sound travels in unfamiliar ways. Light softens. Time itself seems to drift with the currents. Perhaps that is why submarines have fascinated generations of people. They allow us to briefly enter a realm that feels almost like another planet, a place both mysterious and serene, hidden just beneath the familiar surface of our own world. So, find a comfortable position, settle in, and allow your thoughts to drift as gently as the tide. As the shoreline fades behind us and the last rays of sunlight shimmer overhead, our remarkable voyage is about to begin. Together, we'll descend beneath the waves and explore one of history's most extraordinary inventions, following its story from improbable dreams to engineering marvels, all at an unhurried pace. The ocean is calm. The hatch is closed. The ballast tanks begin to fill. And very slowly, almost imperceptibly, we begin our descent. Long before the first submarine slipped quietly beneath the waves, long before engineers understood pressure or inventors sketched complicated machines, humanity had already fallen in love with the mystery of the sea. For thousands of years, the ocean represented the greatest unknown on Earth. Travelers could cross its surface, fishermen could cast their nets into its waters, and sailors could chart its coastlines, but almost no one knew what existed beneath the waves. To ancient civilizations, the sea was not simply a body of water. It was a place of stories. The ancient Greeks imagined magnificent underwater palaces ruled by mighty gods. They believed the sea was the kingdom of Poseidon, whose grand halls were said to be built of coral, gold, and shimmering gemstones hidden beneath the waves. Sea nymphs, mysterious creatures, and strange beasts were thought to inhabit this watery realm, living lives completely unseen by those on shore. Farther north, Norse legends spoke of enormous sea serpents stretching across the ocean. Sailors whispered about monsters large enough to swallow entire ships. While we now understand these tales were born from imagination and the occasional encounter with unfamiliar whales or giant squid, they reveal something deeper about human nature. The oceans inspired both wonder and humility. Some of the earliest attempts to explore beneath the water did not involve machines at all. Instead, they relied upon remarkable divers whose skills seem astonishing even today. Thousands of years ago, pearl divers in places like the Persian Gulf, the Indian Ocean, and the waters surrounding Japan trained themselves to hold their breath for extraordinary lengths of time. With little more than a stone weight to help them descend, they plunged into surprisingly deep waters in search of pearls, shells, and coral. These divers could visit the underwater world, but only for a few precious minutes. The dream of remaining beneath the sea for longer had not yet found its solution. Elsewhere, skilled sponge divers explored the warm waters of the Mediterranean. Their work supplied natural sponges prized throughout the ancient world. Generation after generation, these divers developed remarkable knowledge of underwater landscapes. They memorized reefs, rocky shelves, and hidden passages that remained invisible from above. In many ways, these divers became the first true explorers of the underwater frontier. The desire to extend those journeys gradually inspired another invention, the diving bell. The idea was beautifully simple. Imagine turning a large bell upside down and lowering it carefully into the water. As it descended, air became trapped inside the bell, creating a small pocket where a person could briefly breathe while remaining underwater. The concept may have been known as early as ancient Greece, though the earliest reliable descriptions appear centuries later. Whether made of wood or metal, these early diving bells were heavy, awkward, and limited. They could not travel freely beneath the sea. Still, they represented something extraordinary. For the first time, humans had found a way to carry a tiny piece of the atmosphere with them below the waves. Workers used diving bells to inspect harbor foundations, recover cargo from shipwrecks, and perform underwater construction. Although conditions inside were cramped and damp, the invention demonstrated an important principle. Perhaps humans could survive underwater longer than a single breath allowed. That simple realization planted a seed. As centuries passed, inventors continued wondering whether a vessel might someday move freely beneath the surface instead of remaining attached to a ship above. Of course, imagining such a machine was far easier than building one. Water is an unforgiving environment. Every few feet of depth increased the pressure pushing against a person's body. A small leak can quickly become a disaster. Air is limited. Fire cannot burn. Light disappears surprisingly quickly, leaving only darkness below. Without understanding these challenges scientifically, early thinkers nevertheless recognized that traveling underwater would require an entirely different kind of vessel. Interestingly, some of the first written discussions of underwater travel appeared not in engineering manuals but in stories. Ancient literature occasionally described magical objects capable of descending beneath the sea. These tales were never intended as practical instructions, yet they revealed a persistent fascination with the possibility of exploring hidden waters. History often begins this way. Long before reality catches up, imagination quietly sketches the outline of the future. Even one of history's greatest philosophers spent time thinking about the mysteries of the sea. The Greek philosopher Aristotle carefully observed marine life and described numerous sea creatures with surprising accuracy. Although he never proposed submarines, his careful attention to the underwater world reflected a growing desire to understand rather than merely fear the ocean. Knowledge accumulated slowly. Sailors became better navigators. Shipbuilders constructed stronger vessels. Merchants crossed ever greater distances. Yet despite all these advances, nearly everyone remained confined to the ocean's surface. The underwater world stayed almost entirely hidden. Imagine standing on the deck of an ancient wooden ship during a calm evening. The sea stretches endlessly in every direction, smooth as polished glass. Looking over the side, you might glimpse only a few feet into the clear water before everything fades into deep blue darkness. What lies below? Fish, certainly. Perhaps coral reefs. Maybe forgotten shipwrecks resting quietly on the seabed. Beyond that, no one could say with certainty. That mystery endured for thousands of years. It inspired myths, encouraged exploration, challenged inventors, and quietly waited for someone bold enough to attempt the impossible. The first true submarines were still many centuries away. But every remarkable invention begins long before the first successful machine is built. It begins with a question. What if people could not only sail across the ocean, but journey peacefully beneath it? That question would echo through generations, inspiring dreamers, engineers, and adventurers alike. Before long, one curious inventor living in Renaissance Europe would take the first tentative steps toward turning imagination into reality, bringing humanity one small dive closer to the silent world below the waves. As the centuries passed, humanity's curiosity about the underwater world refused to fade. The stories of sea gods and hidden kingdoms gradually gave way to something different. Across Europe, scholars began asking questions not about magic, but about mechanics. This change was part of a much larger movement known today as the Renaissance. Beginning in the 14th century and flourishing over the next several hundred years, the Renaissance encouraged people to observe the natural world with fresh eyes. It was an age when imagination and engineering often occupied the very same page. Among the greatest thinkers of this era was the remarkable Italian artist and inventor Leonardo da Vinci. Today, Leonardo is remembered for masterpieces like the Mona Lisa and the Last Supper, but painting occupied only part of his extraordinary mind. His notebooks reveal hundreds of inventions that seemed centuries ahead of their time. He sketched flying machines inspired by birds, armored vehicles resembling tanks, bridges that could be assembled in a matter of hours, and intricate mechanical devices powered by gears and pulleys. Naturally, the sea also captured his imagination. Leonardo understood that beneath the surface of the water lay possibilities few others had considered. Although no complete submarine design survives among his writings, several passages suggest he contemplated underwater navigation and even devices that would allow people to remain beneath the surface longer than before. Curiously, Leonardo is said to have deliberately concealed some of his underwater ideas. According to later accounts, he believed certain inventions were too dangerous to publish because they might encourage warfare or acts of sabotage against ships. Whether this story is entirely true remains uncertain, but it reflects an important reality. Even in the early 16th century, thoughtful inventors recognized that powerful technology could be used for both peaceful and destructive purposes. While Leonardo dreamed in Italy, another English thinker approached the problem from a more practical perspective. In 1578, a former naval gunner named William Bourne published one of history's first detailed descriptions of a vessel capable of submerging beneath the sea. Unlike many earlier dreamers, Bourne did not simply imagine an underwater boat. He explained how one might actually work. His proposed vessel would have been enclosed to keep water out while carrying people inside. Most importantly, Bourne realized that controlling buoyancy, the tendency of an object either to float or sink, would be the key to underwater travel. Bourne proposed creating a flexible hull that could be squeezed inward to reduce its volume, making the craft heavier relative to the water it displaced. When expanded again, it would regain buoyancy and rise toward the surface. The design would probably have been extremely difficult, if not impossible, to construct with 16th-century materials. Yet his idea introduced something profoundly important. Instead of relying on magic or mystery, he relied on physics. He treated underwater navigation as an engineering problem waiting to be solved. Still, even the best ideas faced daunting obstacles. The greatest challenge was one that every person understands instinctively: breathing. A person can hold their breath for perhaps a minute or two under ordinary circumstances. Skilled divers might remain underwater much longer, but eventually everyone must return to the surface. An underwater vessel needed a supply of fresh air. No one yet understood oxygen or carbon dioxide as modern science does. Nevertheless, people recognized that air inside a sealed room eventually became unpleasant and difficult to breathe. Another problem involved vision. The deeper one travels beneath the surface, the darker the water becomes. Candles could not safely illuminate a tightly enclosed wooden chamber where oxygen was already limited. Navigation presented another puzzle. Without seeing the shoreline or the stars, how would a submerged vessel know where it was heading? Then came propulsion. On land, wagons used horses. On rivers, boats relied on currents or sails. But beneath the water, where wind could not reach, movement required something entirely different. Human muscles remained the only practical source of power. Inventors imagined oars extending through waterproof seals, hand cranks turning paddles, or crews pushing mechanical levers hour after hour. Every solution demanded tremendous effort while producing only modest speed. And there was one final challenge that frightened nearly everyone who considered the problem: pressure. Although Renaissance scientists did not fully understand underwater pressure, they observed its effects. Divers noticed discomfort in their ears. Wooden barrels sank differently at various depths. Water found even the smallest cracks. The deeper a vessel descended, the greater the force pressing inward from every direction. Without a strong hull, disaster could happen instantly. These obstacles explain why submarine development progressed so slowly. The dream itself was surprisingly simple. The reality proved extraordinarily complicated. Yet something remarkable was happening during these centuries. Inventors scattered across Europe, many of whom never met one another, were beginning to think in similar ways. They sketched enclosed boats. They discussed buoyancy. They imagined underwater propulsion. They searched for methods of carrying air beneath the sea. Each idea, even unsuccessful ones, became another stepping stone. History often advances not through sudden leaps, but through countless quiet attempts. Most of these early concepts never reached the water. They remained in notebooks, manuscripts, or conversations between scholars. But ideas have a curious way of surviving long after their creators are gone. One inventor inspires another. A sketch becomes an experiment. An experiment becomes a prototype. A prototype becomes history. By the dawn of the 17th century, the world had accumulated enough knowledge that someone would finally attempt what generations had only imagined. An ingenious Dutch inventor living in England believed he could build a vessel that would truly travel beneath the water. Unlike those who came before him, he intended to prove it, not with drawings or theories, but by inviting witnesses to watch his remarkable machine disappear beneath the surface of the River Thames. For the first time, the ancient dream of underwater travel was about to become reality. By the beginning of the 17th century, the dream of underwater travel had lingered in the human imagination for generations. Yet, no one had convincingly demonstrated a vessel capable of carrying people beneath the water and returning safely again. Then, quietly, almost unexpectedly, a remarkable inventor appeared. His name was Cornelius Drebbel. Drebbel was born in the Netherlands in 1572. Little about his early life suggested he would one day become one of the pioneers of submarine history. He trained as an engraver, learning precision and patience, but his interests soon expanded far beyond art. He seemed fascinated by almost everything. Friends and patrons often described him as someone who could look at an ordinary object and immediately begin imagining how it might be improved. Eventually, his reputation spread beyond the Dutch Republic and reached the English court. In the early 1600s, Drebbel travelled to England, where he entered the service of James VI and I, better known simply as King James I. The king appreciated unusual inventions and welcomed skilled craftsmen who could entertain as well as educate the royal court. England was an ideal place for Drebbel's restless imagination. At some point around 1620, Drebbel began constructing what many historians consider the world's first practical submarine. Unlike earlier concepts, this vessel was not merely an idea on paper. It was built. The submarine likely began as a sturdy wooden rowing boat. Around this frame, Drebbel stretched carefully treated leather to create a waterproof outer covering. The leather was coated with grease or oil to help repel water, while the seams were sealed as carefully as possible. It was hardly the sleek steel submarine we imagine today. Instead, it probably resembled an ordinary boat wrapped tightly in dark leather, with just enough room inside for a handful of passengers. The crew propelled the vessel using oars. This raises an obvious question. How could oars move through the hull without allowing water to rush inside? No one knows the exact solution Drebel employed, but historians believe he used flexible leather seals around each oar, allowing movement while limiting leaks. It was an ingenious compromise, though undoubtedly imperfect. The submarine's greatest achievement was not speed. It was simply that it could dive. Witnesses reported that Drebel's craft submerged several feet beneath the surface of the Thames while carrying passengers inside. The accomplishment was extraordinary. For the first time, people watched a vessel disappear beneath the river and later emerge again. Imagine standing on the riverbank that day. The morning mist hangs over the Thames. Wooden ships drift nearby, their sails fluttering gently in the breeze. Crowds gather along the shore, whispering among themselves about the strange machine floating near the water's edge. It does not look especially impressive. No towering masts, no polished brass, no roaring engines. Just a curious leather-covered boat preparing for an impossible voyage. The passengers climb aboard. The hatch is secured. Slowly, almost unbelievably, the vessel begins to sink. Not because it is flooding, not because it is failing, but because it is doing exactly what it was designed to do. For several long moments, nothing happens. The river appears perfectly ordinary. Then, somewhere farther downstream, the strange craft rises once more, breaking the surface as calmly as it disappeared. To modern eyes, accustomed to submarines disappearing for months beneath the ocean, the demonstration might seem modest. To those watching in the 17th century, it must have bordered on magic. King James himself is said to have taken a ride aboard Drebel's submarine. Whether every detail of this story is accurate remains uncertain, but several historical sources suggest the king witnessed demonstrations and expressed considerable interest in the invention. If true, it would mean that a reigning monarch personally experienced one of history's earliest underwater voyages. One mystery surrounding Drebel's submarine concerns its air supply. How did the passengers breathe? Some later writers claimed Drebel possessed a secret chemical capable of refreshing stale air. One theory suggests he may have heated a compound known as saltpeter, which releases oxygen when decomposed. While this idea has fascinated historians for centuries, there is little direct evidence proving he actually used such a system. It is equally possible that the submarine simply remained underwater for short periods before resurfacing for fresh air. Whatever the answer, the passengers survived. That alone was remarkable. Yet despite its success, Drebel's invention did not immediately transform naval travel. There were several reasons. The submarine was slow. It relied entirely on human muscle. Its wooden construction limited how deeply it could dive. Navigation beneath the surface remained difficult, and visibility was poor. Most importantly, governments saw little practical use for such an unusual craft. Large sailing ships already dominated trade and warfare. Compared with these mighty vessels, Drebel's little submarine seemed more like an ingenious curiosity than the beginning of a revolution. History often treats groundbreaking inventions this way. The first automobile looked less practical than a horse. The first airplane flew only a short distance. The first computer filled an entire room while performing calculations slower than today's simplest calculator. Transformative inventions rarely appear transformative at first. Instead, they arrive quietly, almost humbly, leaving later generations to recognize their significance. Drebel's submarine eventually faded from public attention. No fleet of underwater vessels followed. No navy rushed to commission dozens more. For a time, it seemed as though the dream of underwater navigation might once again drift into obscurity. But ideas, once demonstrated, are difficult to forget. Somewhere in Europe, another inventor would read about Drebel's remarkable experiment. Another engineer would begin asking new questions. If one submarine could travel beneath a river, perhaps another could cross a harbor. If a handful of passengers could survive below the surface for minutes, perhaps someday entire crews could remain underwater for hours. The possibilities had expanded forever. For the first time in history, humanity no longer wondered whether an underwater boat could exist. Now, the only question was how to build a better one. After the remarkable demonstrations of Cornelius Drebel, the dream of underwater travel had finally become something tangible. People no longer wondered if a vessel could dive beneath the water. They had seen it happen. And yet, despite this extraordinary achievement, the following decades were surprisingly quiet. There were no great fleets of submarines sailing beneath Europe's rivers and coastlines. Kings did not race to build underwater navies. The submarine remained more of a fascinating curiosity than a practical machine. One reason was simple enough. The technology of the 17th century had not yet caught up with the ambition of its inventors. Every dive was an experiment, and every experiment carried significant risks. Still, the idea refused to disappear. Throughout the 18th century, inventors across Europe quietly continued sketching unusual underwater machines. Very few were practical. Even so, each inventor contributed something valuable. One might improve steering. Another might rethink ballast. Someone else experimented with stronger hulls or better seals around moving parts. Progress came slowly, almost patiently. It was as though countless craftsmen were each assembling one tiny piece of an enormous puzzle without realizing what the completed picture would eventually become. Meanwhile, the world above the surface was changing rapidly. European nations were building powerful navies that stretched across the globe. As ships became increasingly important, so too did the idea of protecting, or perhaps secretly approaching, them. It was during this period that submarine inventors began thinking not only about exploration, but also about military possibilities. One man in particular would carry those ideas across the Atlantic. His name was David Bushnell. Bushnell grew up in the American colonies during a time of growing political tension with Great Britain. Unlike many earlier inventors, he approached underwater travel with a very specific purpose in mind. He hoped to build a vessel capable of approaching an enemy ship unnoticed. The result became one of the most famous early submarines ever constructed. It was called the Turtle. Completed in 1775 during the early years of the American Revolution, the Turtle hardly resembled modern submarines. In fact, it looked more like two wooden shells joined together, creating an oval shape that reminded many observers of the animal for which it was named. The vessel was astonishingly small. Only one person could fit inside. The pilot had to steer, propel the submarine, monitor depth, maintain balance, and conserve precious air simultaneously. Simply keeping the Turtle underwater demanded constant concentration. Yet compared with earlier concepts, it represented remarkable progress. Bushnell had developed a workable ballast system that allowed water to enter or leave the vessel as needed. He included gauges to estimate depth. Small windows helped with navigation near the surface. Although primitive by modern standards, these features reflected a growing understanding of underwater engineering. The Turtle was no longer just an experiment. It was becoming a machine. Its most famous mission took place in September 1776. A young soldier named Ezra Lee volunteered to operate the tiny submarine. His objective was ambitious: approach the British warship HMS Eagle while it lay anchored in New York Harbor and attach an explosive charge beneath its hull. The mission began quietly. Under the cover of darkness, Lee climbed inside the cramped vessel and slowly disappeared beneath the water. Imagine the silence. No engine noise. No electric lights. Only the soft creaking of wood, the faint splash of turning propellers, and the steady rhythm of one man's breathing inside a vessel scarcely larger than a barrel. The harbor above remained busy with enormous sailing ships, entirely unaware that something unusual was moving below. Lee successfully reached the Eagle, but another challenge soon emerged. He attempted to drill into the ship's hull to fasten the explosive device, yet he could not secure it. Historians still debate the exact reason. Perhaps he encountered an iron fitting. Perhaps the angle was awkward. Perhaps exhaustion simply made the task impossible. After several attempts, Lee abandoned the effort and withdrew. The explosive later detonated harmlessly in the harbor after drifting away. From a military perspective, the mission failed. From a historical perspective, however, it marked an important milestone. For the first time, a submarine had attempted a covert underwater operation against a warship. Even though the attack was unsuccessful, it demonstrated possibilities that naval planners would continue exploring for centuries. The Turtle itself never entered regular service. It was difficult to operate. Its underwater endurance remained short. Strong currents made navigation extremely challenging. And perhaps most importantly, very few people possessed the strength, patience, and skill required to pilot such a demanding machine. Yet the little wooden submarine earned something perhaps more valuable than immediate success. It earned respect. Inventors around the world took notice. The notion of underwater navigation no longer belonged only to dreamers and philosophers. Real people had built working submarines. They had piloted them beneath rivers and harbors. They had demonstrated that careful engineering could briefly overcome the immense challenges of the underwater world. Still, one great obstacle remained. Everything depended upon human muscles. As long as submarines relied on cranks, pedals, and hand-powered propellers, their speed and endurance would remain severely limited. No matter how clever the design, a tired operator could never compete with the wind filling the sails of a large ship. A new source of power would eventually be needed. That breakthrough still lay decades in the future. But thanks to inventive minds like David Bushnell's, humanity had crossed another important threshold. The submarine was no longer merely a scientific curiosity hidden away in an inventor's workshop. It had become a vessel capable of real missions, real voyages, and real history. The quiet dream of exploring beneath the waves was steadily becoming a practical reality, one careful turn of the hand crank at a time. By the close of the 18th century, the submarine had reached an unusual point in its history. It was no longer an impossible fantasy. The demonstrations of Cornelius Drebbel and the daring experiments of David Bushnell had shown that people could travel beneath the water, at least for short periods. Yet submarines remained rare curiosities. No nation had embraced them. Then another inventive mind entered the story. His name was Robert Fulton. Today, Fulton is most often remembered for developing successful steamboats, but before he transformed river travel, he devoted years to solving another difficult problem: how to build a practical submarine. Born in Pennsylvania in 1765, Fulton possessed the restless curiosity shared by many great inventors. As a young man, he traveled throughout Europe, studying engineering, canals, bridges, and machinery. He believed that technology could reshape transportation, commerce, and even the nature of war. While living in France around the turn of the 19th century, he began designing an underwater vessel that would improve upon everything that had come before. He called it the Nautilus. The name came from the nautilus, a small sea creature that carries its spiral shell wherever it travels. To Fulton, it seemed the perfect symbol for a vessel carrying people safely beneath the sea. Compared with earlier submarines, the Nautilus was remarkably sophisticated. It measured roughly 20 feet in length and featured a streamlined, cigar-like shape that allowed it to move through the water more efficiently. Instead of relying solely on oars, Fulton equipped the submarine with a hand-cranked propeller, one of the earliest practical uses of a screw propeller on an underwater craft. This was an important improvement. The Nautilus also included diving planes and adjustable ballast tanks that helped control its depth. To surface, the crew pumped water back out of the ballast tanks using hand-operated pumps. Although laborious, the system gave the vessel far greater control than many previous designs. Perhaps most impressive of all was its collapsible mast. When traveling on the surface, the Nautilus could raise a small sail and take advantage of the wind, conserving the crew's strength. When it came time to dive, the mast folded down neatly against the hull before the vessel slipped beneath the waves. It was an elegant solution. Fulton conducted a series of demonstrations in French waters, successfully diving the Nautilus and proving that his design worked. Reports suggest it remained submerged for significant periods and reached depths of around 25 feet, quite an achievement for the era. For those fortunate enough to witness these tests, it must have seemed that the future had quietly arrived. Yet building a successful submarine was only half of Fulton's challenge. He also needed someone willing to fund it. At the time, France was led by Napoleon Bonaparte, whose nation was frequently at war with Britain. Fulton believed submarines could provide France with a powerful new advantage by approaching enemy ships undetected. He presented his ideas to French officials with great enthusiasm. The response, however, was cautious. Some military leaders admired the ingenuity of the design but questioned its practicality. Others viewed underwater attacks as dishonorable or unreliable. Large fleets of conventional warships already existed, and few decision-makers wished to gamble on an invention that seemed so unfamiliar. Eventually, the French government declined to support the project. Undeterred, Fulton crossed the English Channel and offered his invention to Britain's leaders instead. It was a curious twist of history. An American inventor who had first sought French support now approached Britain's government with essentially the same proposal. British officials were intrigued enough to examine his work, but they too hesitated. Some worried that submarines might change naval warfare in unsettling ways. Others feared that if Britain embraced such technology, rival nations would inevitably do the same. There is a certain irony here. Both France and Britain recognized that submarines might become important one day. Neither wanted to be the first to rely upon them. As a result, the Nautilus never entered military service. To Fulton, this must have been deeply disappointing. He had solved numerous engineering problems that earlier inventors could scarcely imagine. His submarine handled better, steered more effectively, and demonstrated that underwater navigation was becoming increasingly practical. Yet practical engineering alone was not enough. History often depends upon timing. Sometimes an invention arrives before society is ready to use it. The Nautilus was one such invention. Even without official support, Fulton's work left a lasting legacy. His use of streamlined design influenced later engineers. His propeller demonstrated a more efficient means of underwater propulsion. His ballast systems showed that controlled diving could become routine rather than experimental. Perhaps most importantly, he approached submarine construction as a complete engineering project instead of a daring experiment. He thought carefully about every detail. How should the vessel move? How should it dive? How should it surface? How could the crew conserve energy? How could the craft operate both above and below the water? These questions would continue guiding submarine designers for generations. Looking back, it is remarkable how many modern submarine concepts can be glimpsed in Fulton's work. The sleek hull, the propeller, the ballast tanks, the folding mast for surface travel. None were perfected, but each represented another careful step toward the submarines of the future. Still, one major limitation remained. Every important system depended on human strength. Crew members turned cranks to drive the propeller. They operated pumps by hand. They performed nearly every task through physical effort alone. As long as submarines relied entirely upon muscle power, they would remain slow, exhausting to operate, and limited in range. The next great leap would not come from changing the shape of the vessel. It would come from changing what powered it. The 19th century was about to usher in an age of steam engines, factories, stronger metals, and astonishing new technologies. These inventions would reshape the world above the sea, and before long they would begin transforming the quiet world beneath it as well. The age of experimental submarines was slowly giving way to the age of engineering. For thousands of years, most work had depended on the familiar sources of power that humanity had always known. Then, almost all at once, a new force emerged: steam. Across Britain, Europe, and eventually North America, great iron machines awakened. Factories echoed with the steady rhythm of pistons. Locomotives carried passengers farther and faster than horse-drawn coaches ever could. Massive steamships crossed rivers and oceans without depending entirely on the wind. This remarkable period became known as the Industrial Revolution. Although most people experienced it through railroads, factories, and growing cities, its influence reached even the quiet dream of underwater travel. Inventors who had once struggled with simple wooden boats suddenly found themselves living in an age of stronger materials, improved tools, and increasingly sophisticated engineering. The submarine was about to benefit from all of it. One of the greatest advances came from something surprisingly ordinary: iron. For centuries, wood had been the natural choice for building boats. It floated well, was widely available, and skilled shipwrights understood how to shape it into sturdy hulls. Yet wood also had limitations. It warped over time. It absorbed water. It cracked under pressure. Most importantly, it could only withstand so much force before failing. Iron offered something different. Properly forged, it was stronger, more durable, and capable of supporting far greater loads. Shipbuilders initially hesitated to embrace it. The idea of constructing a boat from metal sounded almost absurd. After all, everyone knew that metal sank. Yet a carefully designed iron hull displaced enough water to float just as well as a wooden one. It was a lesson that surprised many people. By the middle of the 19th century, iron ships were becoming increasingly common. Before long, engineers began asking an obvious question: if iron worked so well above the surface, might it work even better below it? A stronger hull meant a submarine could safely dive deeper than its wooden predecessors, and greater confidence for the crew inside. Progress was not limited to materials alone. Machine tools also improved dramatically. Precision lathes, milling machines, and standardized measurements allowed engineers to manufacture parts with remarkable accuracy. Bolts fit more securely. Valves sealed more tightly. Pumps became more reliable. The submarine was slowly becoming less of an experimental invention and more of a carefully engineered machine. Another challenge receiving renewed attention was air. Every submarine carried only a limited supply. But 19th-century scientists began learning much more about the atmosphere itself. Researchers discovered that air was not a single substance, but a mixture of gases. They learned that humans consumed oxygen while producing carbon dioxide. Although practical systems for refreshing submarine air were still many years away, understanding the problem scientifically was an enormous step forward. You cannot solve a mystery until you understand what the mystery truly is. At the same time, engineers developed better pumps capable of moving water more efficiently. This greatly improved ballast systems. Improved pumps allowed crews to control buoyancy with greater precision. Navigation also advanced. Compasses had guided sailors for centuries, but engineers refined them into more dependable instruments. Better charts mapped coastlines with increasing accuracy. Improvements in optics led to clearer lenses and stronger glass. Inventors even began imagining ways for submarine crews to observe the world above them without exposing the entire vessel. These ideas would eventually lead to one of the submarine's most recognizable features, the periscope. Although practical periscopes were still decades away, the concept itself reflected an important change in thinking. Designers were no longer focused solely on getting underwater. Now they were thinking about operating there efficiently. Perhaps the most difficult challenge remained propulsion. Human muscles had carried submarines this far, but barely. A single sailor turning a crank could propel a submarine only a short distance before exhaustion took over. Even several crew members working together produced limited speed. Some inventors experimented with steam engines. At first glance, they seemed ideal. Steam engines were powerful and increasingly reliable. Unfortunately, they depended upon fire. Fire required oxygen. Inside a sealed submarine, oxygen was already precious. There was also the matter of heat. A steam boiler produced tremendous temperatures, making the cramped interior even more uncomfortable. Worse still, smoke and exhaust gases created obvious problems for any vessel attempting to remain underwater. Some experimental submarines solved this by operating their steam engines only while traveling on the surface. Before diving, the engines would be shut down, and the vessel would rely on stored energy or human power for short underwater journeys. It was an imperfect solution, but imperfect solutions often lead to better ones. Throughout these years, submarine inventors exchanged letters, published designs, and studied one another's successes and failures. Progress no longer depended upon isolated geniuses working alone. Instead, engineering had become a shared conversation stretching across continents. An inventor in France might improve upon an English design. An American engineer might solve a problem first encountered in Sweden. Ideas traveled faster than ever before. By the middle of the 19th century, submarines looked noticeably different from those of Robert Fulton or David Bushnell. They were stronger, better sealed, more carefully balanced, more thoughtfully engineered. Yet they still occupied an uncertain place in history. Most navies admired them with cautious curiosity, but continued investing their resources in large surface fleets. Admirals preferred broadside cannons and towering masts to mysterious underwater vessels whose capabilities remained largely unproven. That hesitation would not last forever. History has a curious habit of accelerating during times of conflict. Before long, a great civil war would divide the United States. Amid the turmoil, engineers on both sides would once again turn their attention beneath the waves. There, in the quiet darkness below the surface, one small submarine would accomplish something no underwater vessel had ever achieved before, forever changing the way the world viewed these remarkable machines. By the middle of the 19th century, submarines had traveled a long and uncertain path. They had begun as impossible dreams drawn in the notebooks of curious inventors. They had become experimental wooden vessels powered by human hands. They had grown stronger through advances in iron, machinery, and engineering. But they were still searching for their moment. That moment arrived during one of the most turbulent periods in American history, the American Civil War. From 1861 to 1865, the United States was divided by a conflict that transformed the nation. Armies marched across fields, great battles were fought on land, and powerful ships patrolled rivers and coastlines. Naval power became increasingly important as both sides sought control of waterways and supply routes. For the Confederate States, facing the much larger industrial power of the Union, finding new advantages became essential. Traditional ships were expensive to build and difficult to match against the Union Navy. A small group of inventors began experimenting with submarine designs that were more advanced than anything before them. Their goal was ambitious: create a vessel that could approach enemy ships silently, a vessel that could travel where ordinary warships could not, a vessel that could change naval warfare forever. One of the earliest Confederate attempts was the Pioneer, built in New Orleans in 1862. Although it never saw combat, it represented an important step forward. It demonstrated that submarines were no longer just theoretical machines. They could be constructed, tested, and refined. As Union forces moved closer to New Orleans, the project was abandoned. But the idea survived. Other inventors continued their work, eventually creating a submarine that would become one of the most famous vessels in naval history. It was called the Hunley. The submarine was named after its main financial supporter and one of its creators, Horace Lawson Hunley. Along with partners James McClintock and Baxter Watson, Hunley helped develop a vessel unlike anything that had existed before. The Hunley was approximately 40 feet long and shaped like a narrow metal tube. Inside, life was incredibly cramped. The crew consisted of 8 men who sat along a central hand-powered crank. There was barely enough room to move. The ceiling was low, the air was limited, and the interior was filled with machinery, controls, and the constant awareness that the surrounding water was only inches away. The submarine had no engine, no electric lights, no comfortable sleeping areas, no way to escape quickly if something went wrong. Every movement depended upon the strength and coordination of the crew. Together, they turned the crank that powered the propeller, slowly pushing the submarine forward through the water. The pace was gentle, almost silent. But silence was exactly what made submarines so interesting. Above the surface, a wooden ship might announce itself with sails, smoke, waves, and movement. Beneath the water, the Hunley could approach unseen. Its weapon was equally unusual. Attached to a long pole extending from the front of the submarine was an explosive charge called a spar torpedo. The idea was simple. The submarine would approach an enemy vessel, place the explosive against its hull, retreat, and detonate the charge. In theory, it was brilliant. In practice, it was incredibly dangerous. The crew had to navigate accurately in darkness while controlling a fragile vessel with limited visibility and limited air. A mistake of only a few feet could mean disaster. The Hunley's first missions revealed just how dangerous submarine warfare could be. Before ever attacking an enemy ship, the submarine suffered several tragedies during testing. In August 1863, it sank during a training exercise, killing its entire crew. Rather than ending the project, however, Confederate leaders recovered the vessel and continued experimenting. The submarine sank again in October 1863, this time killing Horace Hunley himself along with the crew aboard. At this point, many people might have considered the project cursed. Yet its supporters continued believing that the concept itself was valuable. The Hunley was raised once more. A new crew trained aboard the vessel. And eventually, in February 1864, the submarine prepared for the mission that would make it famous. Its target was the USS Housatonic, a Union warship stationed outside Charleston Harbor, South Carolina. On a quiet February night, the Hunley slipped beneath the waves. The crew moved slowly through the dark water, turning the hand crank again and again. Inside the submarine, the atmosphere must have been tense and strangely quiet. Every breath consumed a small amount of precious air. Every movement required effort and concentration. Above them, the crew of the Housatonic continued their watch, unaware that a hidden vessel was approaching. The Hunley reached the ship. The spar torpedo was positioned. The explosive charge detonated. The USS Housatonic sank, becoming the first warship in history to be destroyed by a submarine attack. For the submarine itself, however, the mission ended in mystery. The Hunley never returned. For more than a century, its final resting place remained unknown. The vessel disappeared beneath the same waters it had entered that night, taking its crew with it. In 1970, researchers identified the likely location of the wreck, and in 2000, the submarine was carefully recovered from the ocean floor. Today, the Hunley remains one of the most significant underwater archaeological discoveries ever made. Its story is fascinating because it represents both achievement and tragedy. The Hunley proved that submarines could accomplish something previously considered impossible. A vessel traveling beneath the surface had successfully attacked a powerful warship. But it also demonstrated the dangers of exploring an environment where mistakes could not easily be corrected. The ocean offered no second chances. The Civil War ended in 1865, and the world moved on. Railroads expanded. Cities grew. New technologies transformed daily life. But beneath the surface, another transformation had begun. The Hunley had shown the world that submarines were not merely strange inventions or engineering curiosities. They were powerful machines capable of changing history. The age of the submarine had truly begun. The next challenge would be making these vessels safer, more reliable, and practical enough for regular naval service. The era of experiments was slowly coming to an end. The era of modern submarines was approaching. After the dramatic story of the Hunley, the world began looking at submarines differently. For centuries, underwater vessels had been viewed as fascinating experiments, strange machines created by inventors who dreamed of exploring beneath the waves. Submarines were still incredibly dangerous. The vessel was cramped, difficult to control, and dependent on human strength. Its crew faced limited air, poor visibility, and countless mechanical challenges. If submarines were ever going to become reliable machines, engineers needed to solve problems that had troubled inventors for centuries. They needed better power, better steering, better air systems, and above all, better control beneath the surface. The second half of the 19th century became a period of constant experimentation. Across Europe and North America, inventors refined submarine designs, each attempting to create a vessel that could dive safely, travel farther, and return to the surface with greater reliability. One of the most important improvements came from a simple but revolutionary idea: separate the power source from the underwater environment. Early submarines had depended on human-powered mechanisms or steam engines that could only be used on the surface. Neither solution was ideal. Human-powered submarines were exhausting and slow, while steam engines required fire, fuel, and air. The answer eventually came through electricity. During the late 19th century, advances in batteries and electric motors opened an entirely new possibility. An electric motor could operate without consuming the limited air inside a submarine. Most importantly, it could provide steady underwater movement. Electric power would become one of the defining technologies of submarine development for generations. Another major improvement involved propulsion above the surface. Engineers began combining different power systems together. A submarine could use a traditional engine while traveling on the surface, then switch to electric power after diving. This hybrid approach solved several problems at once. On the surface, the vessel could travel faster and recharge its batteries. Below the waves, it could move quietly without needing oxygen. The concept would eventually become the standard design for submarines throughout the first half of the 20th century. But power was only one part of the challenge. A submarine also needed a reliable way to control its depth. Early inventors understood the basic principle of buoyancy, but controlling movement underwater remained difficult. A submarine that became too heavy could sink dangerously. A vessel that became too light might rise uncontrollably. Engineers improved ballast tanks, creating systems that allowed submarines to carefully adjust their weight and position in the water. They also developed diving planes. Much like the wings of an airplane, these underwater control surfaces allowed submarines to move smoothly downward or upward while maintaining forward motion. With these improvements, diving became less like falling and more like flying. A submarine was no longer simply sinking beneath the waves. It was navigating through another dimension. Steering also improved. Early submarines were difficult to guide because they moved slowly and had limited visibility. Engineers added better rudders and control systems, allowing crews to make more precise adjustments. These changes may have seemed small individually, but together they transformed submarines into far more capable vessels. Another essential invention was the torpedo. Although earlier submarines had experimented with explosive charges attached to poles, torpedoes offered a much more practical weapon. A torpedo could be launched from a distance, travel independently through the water, and strike a target without requiring the submarine itself to make dangerous contact. The development of reliable torpedoes changed how navies viewed submarines. A small underwater vessel could now threaten ships many times its size. The submarine had become a serious military technology. One of the most influential figures of this era was John Philip Holland. Born in Ireland and later moving to the United States, Holland spent decades studying the problems that had limited earlier submarines. He believed the key was creating a balanced design that combined surface travel with effective underwater operation. His designs incorporated many features that would become standard in modern submarines. A streamlined hull, electric motors for underwater travel, gasoline engines for surface movement, improved control systems, a practical torpedo capability. In 1897, Holland completed a submarine known as the Holland 6, a vessel that demonstrated just how far submarine engineering had progressed. Unlike earlier experimental boats, it was designed as a complete military machine. The United States Navy recognized its potential and purchased the vessel in 1900, renaming it USS Holland. It became the first submarine officially commissioned by the United States Navy. This moment represented a major turning point. For the first time, a major world power had accepted submarines as part of its naval forces. Other nations quickly followed. France, Britain, Russia, Japan, and others began developing their own submarine programs. Each country experimented with different designs, but the overall goal was the same: create a vessel that could quietly travel beneath the ocean and provide a new form of naval power. Yet even as submarines became more advanced, life inside them remained challenging. The interiors were still small. The air was still carefully managed. The ocean outside was still dark and unpredictable. Crews needed courage, patience, and technical skill. a submarine was not simply a machine. It was a small world carrying people into an environment where humans were never meant to live. By the beginning of the 20th century, the submarine had finally transformed from an experimental invention into a practical vessel. The journey had taken nearly 300 years. It had begun with wooden boats wrapped in leather. It had passed through hand-powered machines and daring wartime experiments. Now, submarines possessed engines, electric motors, torpedoes, and advanced control systems. The age of the modern submarine had arrived. And soon, these quiet vessels would enter one of the most important chapters in their history, as nations around the world prepared for a new kind of conflict where the greatest battles would sometimes take place far beneath the surface of the sea. By the beginning of the 20th century, the submarine had finally emerged from the realm of imagination and entered the world of practical engineering. A vessel that could travel quietly through the hidden world beneath the waves. A vessel that could carry people safely into an environment where humans had never truly belonged. The journey had been slow. It had begun with diving bells and impossible sketches. It had continued with wooden experiments, hand-powered machines, and daring wartime attempts. Along the way, countless inventors had solved small pieces of the puzzle. Now, those pieces were finally coming together. The submarine was becoming a true machine. One of the most important figures in this transformation was John Philip Holland. Born in Ireland in 1841, Holland developed an early fascination with mathematics, science, and mechanics. After moving to the United States, he devoted much of his life to studying the challenges that had prevented submarines from becoming practical. Many earlier inventors had focused on a single problem. How do you make a boat dive? Holland believed the question needed to be broader. A successful submarine needed to do everything well. It needed to travel on the surface. It needed to dive smoothly. It needed enough power to move underwater. It needed reliable steering. It needed weapons. Most importantly, it needed to be a vessel that sailors could actually operate. Holland approached submarine design with careful balance. His breakthrough design, the Holland 6, combined several technologies that had been developing for decades. It featured a gasoline engine for surface travel and an electric motor for underwater movement. This combination solved one of the greatest challenges facing earlier submarines. When traveling above the waves, the engine could provide speed and recharge the batteries. When submerged, the submarine could rely on quiet electric power. This created a practical rhythm for submarine operations. Surface travel allowed crews to move quickly and prepare for a dive. Underwater travel allowed them to approach unseen. Earlier submarines often looked like unusual boats modified for underwater use. Holland's design looked more like a purpose-built underwater machine. Its rounded hull allowed water to move smoothly around it, reducing resistance and improving efficiency. Inside, the arrangement was carefully planned. There were controls for diving and steering. There were systems for managing the engine and batteries. There was space for a small crew. There were storage areas for supplies and equipment. Compared with earlier submarines, it was still cramped and uncomfortable, but it represented a significant step toward the vessels that would eventually explore the world's oceans. In 1897, the Holland 6 was launched and tested. The trials demonstrated something remarkable. The submarine could travel reliably both above and below the surface. It could dive. It could maneuver. It could return safely. After years of experiments, failures, and abandoned designs, the submarine had finally become a practical invention. The United States Navy recognized its potential and purchased the vessel in 1900, officially commissioning it as USS Holland. This moment marked a turning point in naval history. For the first time, The United States possessed a submarine as part of its official fleet. Other nations quickly began paying attention. France had already been exploring submarine technology and continued developing its own designs. Britain, Russia, and Japan also began investing in underwater vessels. Around the world, naval leaders started to consider a new possibility. The ocean was no longer controlled only from the surface. A second battlefield existed below. Yet the development of submarines was not simply about weapons. It was also about exploration and understanding. The same engineering improvements that made submarines useful for navies also made them better tools for scientific discovery. Stronger hulls allowed deeper dives. Better control systems made underwater exploration safer. Improved equipment allowed crews to study environments that had previously been unreachable. The ocean was beginning to open. But for the sailors who operated these early submarines, life beneath the waves remained challenging. A submarine was a place of constant compromise. Every inch of space had a purpose. Fresh air had to be carefully managed. Water and food supplies had to be planned precisely. Machinery needed constant attention. Crew members worked in shifts, maintaining systems that could never simply be ignored. Unlike sailors aboard large surface ships, submariners lived inside a sealed metal world. They could not step outside for fresh air. They could not look across the horizon. They could not feel the wind or sunlight. They depended entirely on the equipment surrounding them. For many sailors, this created a unique bond between crew and machine. A submarine was not just transportation. It was a living environment. Every valve, gauge, and motor mattered. Every person aboard had an important role. The success of the vessel depended on teamwork and trust. As more countries developed submarines, engineers continued improving their designs. Engines became more reliable. Batteries became more powerful. Hulls became stronger. Navigation systems became more accurate. The submarine was no longer an experiment. It was evolving into a standard part of modern naval strategy. However, many admirals still questioned their value. Traditional naval power remained focused on enormous battleships with heavy armor and powerful guns. These massive vessels represented national strength and dominated naval thinking. Compared with them, submarines seemed almost insignificant. They were small. They carried fewer weapons. They spent much of their time hidden beneath the surface. But their greatest strength was precisely what made some people doubt them. They were difficult to see. They could wait. They could approach silently. They could strike without warning. The world was about to discover just how important that ability could become. As nations entered the 20th century, competition between global powers grew stronger. New alliances formed. Armies expanded. Naval technology advanced rapidly. And beneath the surface of the world's oceans, a new kind of vessel quietly prepared for its greatest test. The submarine had spent centuries trying to prove that it belonged. Soon, history would give it the opportunity. The age of the submarine was no longer approaching. It had arrived. When people imagine submarines today, they often picture enormous steel vessels filled with advanced technology, comfortable control rooms, and crews supported by countless machines. But the earliest submarines were very different. They were small. They were cramped. They were often uncomfortable. The history of submarines is not only a story of inventions and engineering. It is also a story of the people who climbed inside these remarkable machines and accepted the challenge of living in a place where humans were never meant to stay. Submariners needed technical knowledge, patience, courage, and the ability to remain calm in extremely unusual conditions. Aboard a surface ship, sailors could step onto the deck, feel the wind, see the horizon, and know that open air was only a few steps away. Inside a submarine, the world became much smaller. For many early submariners, the first moments after closing the hatch must have felt strange. The sounds of the outside world faded away. The ocean surrounded them. The submarine began to feel less like a boat and more like a small underwater room slowly moving through darkness. Space was one of the greatest challenges. Early submarines were designed around function, not comfort. There was rarely space for anything unnecessary. Crew members often sat shoulder to shoulder. They moved carefully around machinery and pipes. A person could not simply walk around or stretch comfortably. Every movement affected someone nearby. Living aboard a submarine required cooperation. Sleeping arrangements were equally challenging. Many early submarines did not have dedicated sleeping areas. Crews often rested wherever space allowed. A sailor might sleep near machinery, beneath equipment, or beside the very systems that kept the submarine alive. Rest was not always easy. The constant sounds of pumps, engines, and ventilation systems created a background rhythm that never fully disappeared. The air could feel warm and stale. The confined space could become uncomfortable after many hours below the surface. Yet submariners adapted. Humans have always been remarkably skilled at creating routines in unfamiliar environments. Meals aboard early submarines were simple but important. Food had to be stored carefully because there was limited space and no easy way to replace supplies during a voyage. Crews relied on preserved foods that could survive long periods without refrigeration. Fresh ingredients were difficult to carry. A submarine did not have room for luxury. Instead, sailors focused on practical meals that provided energy and could be prepared quickly. Sharing food also became an important part of submarine life. In such a small environment, meals offered a moment of normality. They allowed crew members to sit together, talk, and briefly forget the unusual circumstances surrounding them. Even a simple meal could become a reminder of life above the surface. Fresh air was perhaps the most important resource aboard any early submarine. Unlike a surface ship, where wind constantly refreshes the atmosphere, a submerged vessel carried only the air trapped inside. Every breath mattered. Engineers developed various methods to improve air quality, but early systems remained limited. Crews carefully monitored conditions, knowing that too much time underwater could create serious problems. Carbon dioxide buildup, unpleasant odors, and increasing humidity all affected life below the waves. The crew had to trust their equipment completely. A submarine was not simply carrying sailors through water. It was maintaining a tiny artificial environment. Temperature was another constant challenge. Machinery generated heat, while water surrounding the submarine could be cold. The result was often an uncomfortable combination of warmth, moisture, and condensation. Metal surfaces could become wet. Clothing could remain damp. The interior atmosphere could feel heavy. Yet crews accepted these conditions because they understood the importance of their mission. The submarine offered something no ordinary ship could provide: stealth. A surface vessel announced itself through sails, smoke, and movement. A submarine could disappear. That ability created a unique sense of purpose among early submariners. They were not simply operating machines. They were exploring a new frontier. They were learning how humans could survive in an environment that had always been inaccessible. Navigation beneath the surface was another challenge that required skill. Without a clear view of the outside world, crews depended heavily on instruments. Compasses, depth gauges, and careful calculations guided their movements. A mistake could have serious consequences. A submarine could not simply look toward the horizon and correct its path. The crew had to understand the invisible world around them. They had to know their position without seeing it. This created a special relationship between submariners and their equipment. They learned every sound, every vibration, every change in pressure. A skilled crew could recognize when something was not quite right simply by listening. The submarine communicated with them. By the early 20th century, as submarines became more advanced, life aboard them slowly improved. Designs became larger. Ventilation became better. Equipment became more reliable. Crews received improved training. But the fundamental experience remained the same. A submarine was a place of isolation, a place where a small group of people depended entirely on one another. The friendships formed inside these vessels became one of the strongest traditions of submarine service. When people spend long periods together in a confined environment, trust becomes essential. Every sailor depended on the person beside them. Every task mattered. Every person contributed to the survival of the entire crew. Perhaps that is what makes early submarines so fascinating. The machines themselves were impressive, but the human element was just as remarkable. These sailors entered a world of darkness with limited technology and incomplete knowledge. They accepted discomfort and uncertainty because they believed in the possibilities beneath the waves. They were pioneers, and as submarines continued to develop, these pioneers would soon face their greatest test yet. The beginning of the 20th century brought a new era of global conflict. The quiet vessels that had spent centuries proving themselves would soon find their true purpose in the vast oceans of the world. The submarine was about to enter the age of war. At the beginning of the 20th century, submarines had finally earned their place among the world's naval forces. After centuries of experiments, failures, and gradual improvements, underwater vessels had become reliable enough to operate as part of national fleets. They were faster, stronger, and more capable than the fragile machines of earlier generations. Yet many naval leaders still questioned their true value. The great powers of the world continued to focus on enormous surface fleets. Battleships represented national pride and military strength. Their massive guns, towering structures, and powerful armor dominated naval strategy. Compared with these giants, submarines seemed almost insignificant. They were smaller. They carried fewer weapons. They spent much of their time hidden beneath the waves. But their greatest advantage was also their most mysterious quality. They could disappear. A battleship announced its presence from miles away. A submarine could wait silently beneath the surface, unseen and unpredictable. As Europe moved closer to war in the early 20th century, that ability became increasingly important. In 1914, tensions between the world's major powers finally erupted into conflict with the beginning of World War I. The war transformed nearly every aspect of military technology. Aircraft took to the skies in combat. Tanks appeared on battlefields. Radio communication became increasingly important. And beneath the oceans, submarines entered a new chapter of history. The German Empire quickly recognized the potential of submarines, known as U-boats. The term came from the German phrase Unterseeboot, meaning undersea boat. Germany faced a difficult naval situation. The British Royal Navy was one of the most powerful fleets in the world, controlling vital sea routes and maintaining a large number of surface ships. Germany could not easily challenge Britain ship for ship. Submarines offered another strategy. Instead of fighting massive battleships directly, Germany could use U-boats to attack supply lines and weaken the enemy over time. The idea was simple. If Britain depended on ships carrying food, fuel, weapons, and materials. Then submarines could threaten the flow of those supplies. The ocean itself could become a battlefield. Early U-boats were still limited compared with later submarines. They were relatively small. Their range was restricted. Their crews worked in difficult conditions. Many could only remain underwater for limited periods before needing to surface and run their engines. Yet they possessed something extremely valuable: surprise. A submarine could approach a ship without being seen until it was ready to attack. Its primary weapon was the torpedo. Unlike earlier explosive devices attached directly to submarines, torpedoes allowed vessels to strike from a distance. A submarine could remain hidden while launching a self-propelled weapon toward a target. This changed naval warfare forever. For centuries, ships had fought by seeing one another, maneuvering into position, and exchanging gunfire. Submarines introduced a different kind of combat. The enemy might never know where the attack came from. The ocean became a place of uncertainty. At first, many attacks focused on military vessels, but as the war continued, German U-boats increasingly targeted merchant ships carrying supplies to Britain and its allies. This strategy became known as unrestricted submarine warfare. The decision was controversial because many of the targeted ships were civilian vessels. One of the most famous moments of the war occurred in 1915, when the British passenger liner RMS Lusitania was torpedoed by a German U-boat off the coast of Ireland. The sinking caused international outrage, especially because civilians were among the thousands of people aboard. The tragedy influenced public opinion, particularly in the United States, where many people viewed the attack with alarm. The Lusitania became a powerful symbol of the dangers of submarine warfare. It also revealed one of the greatest challenges surrounding this new technology. Submarines were incredibly effective, but they created difficult moral and strategic questions. How should a hidden weapon be used? Could submarines attack without warning? How should nations balance military goals with the safety of civilians? These questions would continue following submarines throughout the 20th century. As the war progressed, Allied nations developed new ways to defend against U-boats. Ships began traveling in groups called convoys, making them more difficult targets. Naval forces developed improved detection methods and specialized anti-submarine weapons. The underwater battle became a constant contest between attack and defense. Submarines improved. So did the methods used to find them. Each side searched for the next advantage. For the sailors inside U-boats, life was demanding. Crews spent long periods away from the surface, surrounded by machinery and limited supplies. The atmosphere inside could become uncomfortable. Space was scarce. The pressure of constant danger weighed heavily. A submarine mission required patience. A crew might spend hours or days searching for targets, moving silently through the ocean while waiting for the right moment. The tension could be overwhelming. One moment, the submarine might be completely still beneath the waves. The next, alarms might sound as enemy ships approached. Every decision mattered. Every mistake could be fatal. By the end of World War I, submarines had proven that they were no longer experimental weapons. They had become a major force in naval strategy. They had changed the way nations thought about the ocean. The surface was no longer the only place where wars were fought. A second battlefield existed below. When the war ended in 1918, the world had changed forever. Millions of lives had been lost. Nations had risen and fallen. Military technology had advanced at an astonishing pace. And beneath the waves, the submarine had completed one of the greatest transformations in its history. It had begun as a dream. It had become a machine. Now, It had become a symbol of the hidden power of the ocean. But the story of submarines was far from finished. The years between the world wars would bring new designs, new discoveries, and new questions about how these silent vessels would shape the future. When the First World War ended in 1918, the submarine had proven itself as one of the most influential inventions in naval history. A vessel that had once been dismissed as impractical had changed the way nations thought about the ocean. Submarines had demonstrated that a small, hidden craft could challenge powerful surface fleets and force countries to rethink traditional ideas about naval warfare. But the end of the war also created a difficult question. What would happen to submarines now? For many nations, the answer was complicated. The devastation of World War I led to efforts to limit military expansion. Countries wanted to prevent another conflict on the same scale, and new agreements attempted to restrict certain weapons. The Washington Naval Treaty placed restrictions on battleships and other major naval forces. Submarines were also discussed, with some nations questioning whether these hidden weapons should even exist. Yet despite concerns about submarine warfare, few countries were willing to abandon the technology entirely. The lessons of the First World War were too important. Everyone now understood that submarines could influence the outcome of a conflict. During the years between the world wars, engineers focused on making submarines better rather than simply making more of them. They worked to improve range, speed, reliability, and comfort. The submarine was becoming a more refined machine. One major improvement was the development of larger and more capable vessels. Early submarines had often been limited in size, carrying small crews and operating close to shore. Newer designs were built to travel farther into open oceans and remain away from their home ports for longer periods. These larger submarines could carry more fuel, more supplies, and more weapons. They became true ocean-going vessels. However, designers faced an interesting challenge. A submarine needed to succeed in two very different environments. Above the water, it needed speed and efficiency. Below the water, it needed silence and endurance. This led to the continued use of hybrid propulsion systems. Diesel engines powered submarines while they traveled on the surface. When it was time to dive, the crew switched to electric motors powered by batteries. The transition was carefully planned. While running on the surface, the diesel engines could recharge the batteries so the submarine would be prepared for underwater operations later. It was a clever compromise. The technology of the time could not yet create a submarine that could remain underwater indefinitely, but engineers were finding ways to make the vessel increasingly effective. Another important improvement was the submarine's shape. Early designs often resembled boats that happened to travel underwater. Over time, engineers realized that the best underwater vessels needed to be shaped specifically for movement through water. The rounded, streamlined hull became increasingly common. The goal was simple: reduce resistance, move more efficiently, waste less energy. The submarine was beginning to look less like a modified ship and more like a true underwater vehicle. Inside, life also improved. Submarines became larger, allowing crews slightly more space to live and work. Ventilation systems improved. Equipment became more reliable. Navigation tools became more accurate. Yet submarine life remained demanding. A crew could still spend weeks inside a narrow metal environment, separated from the outside world by only a few inches of steel. The submarine remained a place where teamwork was essential. Every sailor had responsibilities. Every system needed attention. Every person depended on everyone else. During this period, submarines also became important tools beyond warfare. Scientists and explorers began using improved underwater vessels to study the oceans. Researchers wanted to understand marine life, underwater geology, and the mysterious depths that remained largely unexplored. The submarine offered humanity a new way to visit places that had always been hidden. It became a bridge between the familiar world above and the unknown world below. Perhaps the most exciting developments of the era came from advances in underwater navigation. One of the greatest challenges of submarine travel had always been knowing where the vessel was when it could no longer see the surface. Better compasses, improved charts, and more accurate instruments helped crews navigate with greater confidence. The invention of sonar technology would eventually transform underwater exploration completely. By sending sound waves through the water and measuring their reflections, sonar allowed submarines to detect objects they could not see. The ocean was dark, but it was no longer completely invisible. By the late 1930s, several nations had developed impressive submarine fleets. The United States, Britain, Japan, Italy, France, and Germany all recognized the strategic importance of underwater vessels. Each nation had different goals. Some focused on defending coastlines. Others wanted long-range attack submarines capable of operating across entire oceans. Japan, with its island geography, placed particular importance on submarines that could extend its naval reach throughout the Pacific. Britain viewed submarines as both offensive weapons and tools for protecting vital shipping routes. The United States continued developing larger and more capable vessels designed for operations across the vast Pacific Ocean. And Germany, despite restrictions placed after World War I, secretly rebuilt its submarine forces. By the late 1930s, the world was once again moving toward conflict. The peaceful years between wars had given engineers time to refine submarine technology. They had created vessels that were faster, stronger, and more reliable than anything that had existed before. But they had also created weapons that could be more powerful than previous generations had imagined. When global war returned in 1939, submarines would play one of their most important roles yet. The quiet vessels beneath the waves would become central to battles that stretched across the Atlantic and Pacific Oceans. Crews would spend months at sea. Entire supply lines would depend on their success, and the world would discover that the submarine had become one of the most powerful tools of modern warfare. The age of the submarine had arrived. Now, it was about to enter its most famous chapter. When the world entered the Second World War in 1939, submarines had already proven their importance. The lessons of the First World War had not been forgotten. Nations understood that submarines could threaten supply lines, disrupt enemy movements, and force entire fleets to change their strategies. But the submarines of the Second World War were far more advanced than those of the previous conflict. At the beginning of the war, Germany once again placed great importance on submarine warfare. The German U-boat fleet had been rebuilt after the restrictions that followed World War I. Under the leadership of Naval Commander Karl Dönitz, Germany developed a strategy focused on using submarines to attack Allied shipping in the Atlantic Ocean. The goal was not necessarily to destroy enemy warships. Instead, Germany aimed to cut the supply lines that kept Britain alive. The British Isles depended heavily on ships bringing food, fuel, weapons, and raw materials from across the world. If those shipments could be stopped, German leaders believed Britain could be weakened into surrender. The Atlantic Ocean became a vast battlefield. But unlike traditional naval battles, much of this conflict happened out of sight. Far below the surface, in the darkness, the German U-boats hunted silently. From inside their narrow steel vessels, sailors monitored equipment, maintained machinery, and waited patiently for opportunities to appear. Life aboard a U-boat was demanding. The submarine was crowded with men, supplies, fuel, and equipment. Every available space had a purpose. Food was stored wherever it could fit. Machinery filled much of the interior. Sleeping areas were limited. The environment could become uncomfortable quickly. The air grew warm and humid. The smell of machinery, food, and people filled the narrow passageways. Yet the crews adapted. Like submariners before them, they created routines and relied on teamwork. The most famous German submarine strategy was called the Wolf Pack. Instead of operating alone, groups of U-boats would spread out across the ocean searching for Allied convoys. Once a submarine located a group of ships, it would report the position to others nearby. Then, several submarines could attack together. The name was fitting. Like wolves hunting together, the U-boats worked as a coordinated group, surrounding their targets and striking from multiple directions. At first, this strategy was devastatingly effective. In the early years of the war, German submarines sank enormous amounts of Allied shipping. Merchant vessels disappeared beneath the waves, and nations struggled to protect their vital supply routes. For a time, it seemed as though the Atlantic Ocean itself belonged to the submarines. This period became known as the Battle of the Atlantic. It was one of the longest campaigns of the entire war. The Allies faced a difficult challenge. How do you fight an enemy you cannot easily see? A submarine could hide beneath the surface and wait patiently for the right moment. Traditional weapons were often ineffective because ships could not know exactly where the submarine was located. To counter this threat, the Allies developed new technologies and strategies. One of the most important was the convoy system. Instead of allowing merchant ships to travel alone, groups of vessels would move together while protected by escort ships. These escorts carried weapons designed specifically for submarine defense. Aircraft also became increasingly important. Planes could patrol large areas of ocean, search for submarines, and attack vessels that surfaced to recharge their batteries. Another revolutionary technology was sonar. Known by the Allies as Arstic, sonar used sound waves to detect objects beneath the water. It gave ships a way to locate submarines that could not be seen from the surface. The ocean was still vast. The submarine was still hidden. But it was no longer invisible. As the war continued, the balance slowly shifted. Allied forces improved their ability to detect and destroy U-boats. More escort ships were built. Air patrols expanded. Intelligence operations helped reveal German submarine movements. Technology became locked in a constant competition. Submarines became quieter and more capable. Detection systems became more sensitive. Each side searched for the next advantage. Meanwhile, another submarine war was unfolding across the Pacific. The United States Navy developed a different approach. Unlike Germany's focus on the Atlantic supply routes, American submarines targeted Japanese naval forces and merchant shipping throughout the Pacific Ocean. The Pacific presented unique challenges. It was enormous. Distances were measured in thousands of miles. Submarines needed long-range, reliable equipment, and crews capable of spending extended periods away from home. American submarines became essential to the island-hopping strategy used against Japan. They attacked supply ships, gathered intelligence, rescued downed pilots, and disrupted Japanese operations. Although often operating far from public attention, American submariners played a major role in the eventual Allied victory. Their missions required patience and courage. A submarine patrol could last for weeks. Days might pass without contact with the enemy. Then, suddenly, everything could change. An alarm could sound. A target could appear. The crew would rush into action. The submarine would prepare to attack. And moments later, it might disappear again into the endless Pacific. By the end of World War II, submarines had become among the most respected and feared weapons of the modern age. They had changed naval warfare forever. The ocean was no longer simply a highway for ships. It was a three-dimensional battlefield. Above the surface, fleets fought with guns and aircraft. Below, submarines moved silently through the darkness. The war also accelerated submarine technology. Engineers developed better batteries, improved sonar systems, stronger hull designs, and more efficient propulsion methods. But perhaps the greatest lesson of the war was that submarines were not finished evolving. The vessels of World War II still needed to surface regularly for air and power. They were powerful, but they were limited. The next great transformation would change everything. A new source of energy would allow submarines to remain beneath the waves for months instead of days. They would become faster, larger, and capable of traveling across the entire globe without ever needing to surface. The submarine was about to enter the nuclear age. When the Second World War ended in 1945, submarines had proven their importance beyond any doubt. They had helped shape the outcome of battles across the Atlantic and Pacific Oceans. But despite all their achievements, World War II submarines still had one major weakness. They had to come back to the surface. Diesel-electric submarines were powerful machines, but they depended on the air above the ocean. Their diesel engines could only operate while surfaced or using specialized equipment called snorkels that allowed them to draw in air while remaining mostly hidden. Underwater, they relied on batteries. Eventually, those batteries ran low. A submarine could hide for a while, but it could not remain beneath the waves forever. Then, a new technology changed everything. Nuclear power. The discovery of nuclear energy in the 20th century opened possibilities that earlier submarine designers could only have imagined. Instead of relying on engines that required oxygen, submarines could use a nuclear reactor to produce enormous amounts of energy for years at a time. The submarine was about to become a true underwater vessel, not a ship that occasionally traveled beneath the surface. A ship that belonged there. The first person to seriously imagine this future was Hyman Rickover. Often called the father of the nuclear navy, Rickover believed that atomic energy could completely transform naval technology. He saw that nuclear reactors could provide submarines with a nearly unlimited source of power. The challenge was enormous. A nuclear reactor had to be made small enough to fit inside a submarine. It had to operate safely. It had to provide reliable power for long missions. And it had to function in one of the most unforgiving environments on Earth. Through years of research and engineering, scientists and naval designers made this dream possible. The result was USS Nautilus, SSN 571. Launched in 1954, the USS Nautilus changed submarine history forever. At first glance, it looked similar to earlier submarines. It was a long, steel vessel designed to move through the ocean. But inside was something revolutionary. A nuclear reactor. The reactor produced heat through nuclear fission, splitting atoms to release energy. That heat created steam, which powered turbines connected to the submarine's propulsion system. Unlike diesel engines, the reactor did not need oxygen. The submarine could remain underwater for extraordinary periods of time. The limitations that had shaped submarine design for centuries were suddenly disappearing. The Nautilus could travel farther. It could move faster. It could stay hidden longer. It could operate beneath the waves in a way no submarine had ever done before. In 1958, the Nautilus achieved one of the most famous voyages in submarine history. It traveled beneath the Arctic ice and became the first vessel to reach the North Pole. The journey was remarkable not only because of the distance traveled, but because of what it represented. For centuries, explorers had struggled with the frozen Arctic environment. Ships became trapped in ice. expeditions faced incredible hardships. Now, a submarine quietly passed beneath the frozen surface. The ocean had become a pathway. The impossible had become routine. The nuclear revolution transformed more than just propulsion. It changed the size and purpose of submarines. Without the need for frequent surfacing, submarines could become larger and carry more equipment. They could operate independently for months. They could travel across entire oceans without returning to port. This created two new categories of submarines that would define the Cold War era. The first was the attack submarine. These vessels were designed to hunt and destroy enemy ships and submarines. They focused on speed, stealth, and advanced sensors. The second was the ballistic missile submarine. These submarines carried long-range nuclear missiles and became one of the most important parts of nuclear deterrence. The idea was simple but terrifying. A country's nuclear submarines could hide almost anywhere in the world's oceans. Even if an enemy destroyed land-based weapons, hidden submarines could still respond. Because of this, submarines became part of a strategy known as mutually assured destruction. The presence of these hidden weapons meant that launching a nuclear attack could result in devastating retaliation. In a strange way, submarines became instruments designed to prevent war. Their power came not only from what they could destroy, but from the fear that they could never be completely eliminated. The Cold War transformed the ocean into another arena of competition between the United States and the Soviet Union. American and Soviet submarines quietly followed one another through the depths. They listened. They watched. They gathered information. They practiced. Many of these missions remained secret for decades. The ocean became a world of silent encounters where crews could spend months separated from the surface, surrounded by darkness and pressure. Life aboard nuclear submarines was different from earlier submarines, but it remained demanding. Crews lived in a carefully controlled environment far from sunlight and fresh air. They worked long shifts maintaining complex nuclear systems, navigation equipment, sonar technology, and weapons systems. The submarine itself became a small self-contained world. Food supplies had to last. Equipment had to function perfectly. Every sailor depended on the training and discipline of everyone around them. Yet nuclear power also brought new possibilities for exploration. Submarines could travel deeper and farther than ever before. They could study the ocean floor, observe marine life, and support scientific missions in places that had once been unreachable. The same technology developed for military purposes also expanded humanity's understanding of the planet. By the second half of the 20th century, submarines had become among the most advanced machines ever created. They combined nuclear physics, engineering, navigation, and computer technology into a vessel capable of traveling silently through a world of complete darkness. The journey that began with a leather-covered wooden boat on the Thames had reached a place few could have imagined. The submarine was no longer simply a machine that entered the ocean. It had become a machine built for the ocean. And beneath the waves, hidden from view, these remarkable vessels would continue to shape history through exploration, science, and the quiet balance of global power. After the invention of nuclear-powered submarines, the role of these remarkable vessels changed forever. For centuries, submarines had been defined by limitation. They had to surface for air. They had to conserve energy. They had to carefully choose when and where they could operate. But nuclear power removed many of those restrictions. A submarine could now travel thousands of miles. It could remain hidden beneath the waves for months. It could cross oceans without being detected. The ocean, once a barrier, became a vast hiding place. And during the Cold War, that hiding place became one of the most important strategic environments on Earth. Following the end of the Second World War, the world entered a tense rivalry between two superpowers, the United States and the Soviet Union. This period became known as the Cold War. Unlike previous conflicts, the United States and Soviet Union rarely fought each other directly. Instead, they competed through technology, politics, intelligence, and military strength. At the center of this competition was a frightening new reality. Nuclear weapons had the power to destroy entire cities. Both nations built enormous arsenals of nuclear missiles, creating a dangerous balance where neither side could attack without risking devastating retaliation. Submarines became a crucial part of this balance. Hidden beneath the ocean, nuclear-powered ballistic missile submarines offered something unique: survivability. Land-based missiles could be located. Air bases could be attacked. Surface ships could be tracked. But a submarine traveling silently through the vast ocean was extremely difficult to find. This made it one of the most powerful deterrents in the world. The idea was simple. If an enemy launched a nuclear attack, hidden submarines would still be able to respond. Because no nation could guarantee the destruction of every submarine, launching a first strike became far more dangerous. The submarines themselves helped maintain an uneasy peace. The United States developed a new generation of ballistic missile submarines known as the Polaris submarines. These vessels carried nuclear missiles capable of traveling thousands of miles. They were designed not for traditional battles, but for the possibility of the unthinkable. Their mission was to remain hidden, ready, and prepared. The Soviet Union developed its own submarine forces in response. A silent competition unfolded beneath the waves. American and Soviet submarines followed each other through the oceans, sometimes coming dangerously close without either side knowing exactly what the other was doing. These encounters were often called a game of underwater chess. Each submarine captain had to think carefully. Move too aggressively, and you might reveal your position. Move too cautiously, and you might lose valuable information. The ocean became a place where patience and skill mattered as much as technology. Attack submarines played another important role during the Cold War. While ballistic missile submarines focused on nuclear deterrence, attack submarines were designed to hunt. Their targets included enemy submarines, surface ships, and intelligence-gathering vessels. These submarines became faster, quieter, and more sophisticated. The goal was not simply to move underwater. The goal was to disappear. Stealth became the defining characteristic of submarine design. Engineers worked constantly to reduce noise. Every mechanical vibration could reveal a submarine's location. Pumps, engines, propellers, and even the movement of the crew could create sounds detectable by enemy sonar systems. Modern submarines became carefully engineered environments where every detail mattered. Special materials reduced vibrations. Improved propeller designs lowered noise. Advanced navigation systems allowed crews to travel with incredible precision. The submarine was becoming a machine built around silence. One of the most important technologies of this era was sonar. Sonar allowed submarines and ships to detect objects underwater by sending out sound waves and analyzing the echoes that returned. But sonar created a constant technological race. As detection systems improved, submarines became quieter. As submarines became quieter, sonar systems became more sensitive. Each advancement created a need for another. The ocean became a battlefield of sound. Even though submarines were hidden, their crews experienced the pressures of Cold War operations every day. Life aboard a nuclear submarine required discipline and concentration. Crews could spend months away from home. They lived in a controlled environment with no sunlight and no direct connection to the outside world. A sailor might go weeks without seeing the surface. Time was measured by schedules, duties, and routines rather than sunrise and sunset. Despite the isolation, submarine crews developed strong traditions. They depended on one another completely. A nuclear submarine contained incredibly complex systems, and every person aboard had an important responsibility. The reactor operators, the engineers, the navigation teams, the sonar specialists. Everyone contributed to the safety and success of the mission. The submarine was a community hidden beneath the ocean. The Cold War also pushed submarines into scientific exploration. Because nuclear submarines could travel farther and deeper than ever before, they became valuable tools for studying the oceans. They helped researchers understand deep-sea environments, ocean currents, and underwater geography. Technology created for military purposes also expanded humanity's knowledge of the planet. By the end of the 20th century, submarines had become among the most advanced machines ever built. They represented the combination of physics, engineering, computer science, and human courage. From the tiny wooden turtle of the American Revolution to the enormous nuclear submarines of the Cold War, the journey had been extraordinary. The submarine had evolved from a fragile experiment into a vessel capable of changing global history. Yet even with all this progress, the ocean still held mysteries. The deepest parts of the sea remained largely unexplored. Scientists and engineers continued searching for new ways to travel beneath the waves. The submarine was no longer only a weapon. It had become a gateway, a way to explore the final frontier on Earth. And in the decades that followed, submarines would continue carrying humanity deeper into the unknown. Although submarines were originally developed for military purposes, they also became some of humanity's greatest tools for exploration. They allowed scientists, engineers, and explorers to enter a world that had previously been almost completely inaccessible. The submarine transformed the ocean from a barrier into a place of discovery. Early explorers understood that reaching the deep sea would require specially designed vessels. Ordinary submarines built for naval warfare were not always suited for extreme depths. They were designed to move quickly, carry weapons, and operate strategically, not necessarily to withstand the crushing pressure found thousands of feet below the surface. A different kind of underwater craft was needed. These vehicles were known as submersibles. Unlike traditional submarines, which could travel independently for long periods, many submersibles were designed specifically for scientific missions. They focused on reaching extreme depths and allowing humans to observe the underwater world directly. One of the earliest pioneers of deep-sea exploration was Auguste Piccard. In the mid-20th century, Piccard developed a deep-diving vessel called a bathyscaphe. The name combined the Greek words for deep and ship, reflecting its purpose as a craft built for the deepest parts of the ocean. The design was unlike ordinary submarines. A large float filled with lighter-than-water materials allowed the vessel to descend and rise. A strong pressure-resistant capsule carried the crew safely inside. This capsule was essential. At great depths, water pressure becomes extraordinary. Every square inch of the vessel experiences enormous force from the surrounding ocean. A normal ship would be crushed. A normal submarine might not survive. But a carefully designed pressure sphere could protect the people inside. In 1960, Piccard's son Jacques Piccard and United States Navy officer Don Walsh achieved one of the greatest milestones in underwater exploration. They descended in the bathyscaphe Bathyscaphe to the Challenger Deep, the deepest known point in the oceans. The journey took them nearly 7 miles beneath the surface. Inside their tiny pressure capsule, they entered a place where no human had ever traveled before. The darkness was complete. The pressure was unimaginable. The environment was unlike anywhere on the surface world. Yet they reached the bottom safely. Their achievement demonstrated something extraordinary. The deepest parts of Earth were no longer unreachable. Humans could enter the abyss. As exploration continued, scientists discovered that the deep ocean was far more complex than anyone had imagined. For centuries, many people believed the deep sea was almost lifeless. The darkness and cold seemed too extreme for most organisms. But submarines and deep-sea vehicles revealed a surprising truth. The ocean floor was filled with life. Strange creatures adapted to environments completely different from those near the surface. Some produced their own light through bioluminescence. Others survived under enormous pressure and with very little energy. The deep ocean was not empty. It was a hidden ecosystem. Submarines allowed scientists to observe these environments directly, rather than relying only on samples collected from the surface. They could study underwater landscapes, geological formations, and marine species in their natural surroundings. The ocean became a place of first-hand exploration. Submarines also helped scientists discover features of the Earth itself. The seafloor contained mountain ranges, deep trenches, volcanoes, and vast plains. Much of this landscape had remained unknown until underwater technology advanced. One of the most important discoveries came from studying hydrothermal vents. These underwater springs, found along volcanic regions of the seafloor, released extremely hot, mineral-rich water from beneath Earth's crust. Around these vents, scientists discovered entire communities of life that did not depend on sunlight. Instead, organisms survived through chemical energy. This changed scientific understanding of life itself. It suggested that life might exist in extreme environments elsewhere in the universe, far from the warmth and light of a star. The submarine had become more than a vehicle. It had become a scientific instrument. Beyond exploration, submarines also played important roles in underwater archaeology. Ancient shipwrecks that had rested unseen for centuries could finally be studied. Researchers could examine lost vessels, recover artifacts, and learn more about human history beneath the waves. The ocean floor became an underwater archive. Every wreck carried stories. Stories of exploration. Stories of trade. Stories of disasters and human courage. Modern submersibles continued improving throughout the late 20th and early 21st centuries. Robotic vehicles expanded exploration even further. Unlike crewed submarines, remotely operated vehicles could descend to extreme depths without risking human lives. They carried cameras, sensors, and scientific equipment into places where humans could not easily travel. Together, submarines and robotic explorers have revealed only a fraction of the ocean's secrets. Even today, the deep sea remains one of the least explored environments on Earth. This is perhaps what makes submarines so fascinating. They represent humanity's desire to explore. For thousands of years, people looked toward distant horizons and wondered what existed beyond them. Eventually, we explored the skies. But beneath our own oceans remained another unknown world. Submarines gave us a way to enter that world. They carried humans into darkness and returned with knowledge. They showed us that the planet beneath the waves was not silent or empty, but alive with movement, mystery, and wonder. From the first fragile diving vessels to modern deep-sea explorers, submarines have always represented the same dream: to go somewhere humans have never been, to discover what has been hidden, and to understand the vast world that exists beneath the surface of our own planet. Submarine development did not stop with nuclear power. The modern submarine continued to evolve. New materials, computer systems, sensors, and engineering breakthroughs created vessels that were quieter, smarter, and more capable than earlier generations could have imagined. The submarine had entered the digital age. one of the most important goals of modern submarine design, has remained the same since the beginning: stealth. A submarine's greatest advantage is its ability to remain hidden. Unlike aircraft or surface ships, which can often be seen from great distances, submarines operate in an environment where visibility is extremely limited. Their survival depends on avoiding detection. For this reason, modern submarines are designed around silence. Every sound matters. A turning propeller, a moving pump, a cooling system. Even the movement of equipment inside the vessel can create vibrations that travel through the water. Enemy submarines and ships use sonar systems to listen for these sounds. Because of this, engineers have spent decades reducing every possible source of noise. Modern submarines use special materials and advanced construction methods to absorb vibrations. Machinery is mounted on systems designed to isolate movement. Propeller designs have been carefully refined to create less disturbance in the water. The result is a vessel that can move through the ocean almost silently. The modern submarine is not simply hidden. It is nearly invisible. Another major transformation has come from computers. Early submarines depended heavily on manual calculations and mechanical instruments. Crews had to carefully measure speed, depth, direction, and position using limited tools. Today, submarines contain powerful computers that process enormous amounts of information. Navigation systems can calculate precise positions. Sensors can analyze the surrounding ocean. Sonar systems can create detailed pictures of underwater environments. The submarine has become a floating technology center. Yet despite all these advances, the role of the human crew remains essential. A submarine is still operated by people who must make decisions, solve problems, and work together under difficult conditions. Life aboard a modern submarine is still unlike life anywhere else. Many submarines spend months at sea. Crew members live in a controlled environment far below the surface world. They experience no natural sunlight. They cannot see the weather outside. They measure time through schedules and routines rather than the rising and setting of the sun. The submarine becomes their entire world. Meals, work, rest, and recreation all happen within the same narrow vessel. Modern submarines are larger and more comfortable than their predecessors, but space is still carefully managed. Every area has a purpose. Equipment, supplies, and living spaces must all fit together efficiently. The crew develops a unique relationship with the vessel. They know its sounds. They understand its systems. They notice small changes that might indicate a problem. A submarine becomes more than a machine. It becomes a home beneath the waves. Modern submarines also continue to serve important military roles. Attack submarines remain among the most capable naval vessels in existence. They can track enemy ships, gather intelligence, protect fleets, and conduct specialized missions. Because of their stealth and endurance, they can operate in areas where other ships cannot safely travel. Ballistic missile submarines continue to serve as part of nuclear deterrence strategies. Their ability to remain hidden for long periods provides nations with a powerful second strike capability. These vessels represent one of the most serious responsibilities in the world. Their missions require extraordinary discipline and careful decision-making. But submarines are not only tools of warfare. They continue to support exploration and science. Modern research submarines and submersibles allow scientists to study the ocean in incredible detail. They examine deep-sea ecosystems, underwater geology, and the effects of climate change on marine environments. Robotic underwater vehicles have expanded exploration even further. These machines can travel into places too dangerous or too deep for humans. They collect information, capture images, and help scientists understand parts of the ocean that remain mysterious. The relationship between humans and submarines has always been about curiosity. The same technology that allows a submarine to hide from an enemy also allows scientists to discover unknown worlds. The ocean remains one of Earth's greatest frontiers. Even today, much of the deep sea remains unexplored. There are mountains beneath the waves taller than those on land. There are valleys deeper than many people realize. There are countless species still waiting to be discovered. Submarines continue carrying humanity into this hidden world. Perhaps the most remarkable thing about the modern submarine is how far it has come from its humble beginnings. The first inventors dreamed of simply staying underwater for a few minutes. Modern submarines can remain beneath the waves for months. Early crews turned hand cranks to move through the water. Modern vessels use nuclear reactors and advanced propulsion systems. Early submarines navigated by simple instruments. Modern submarines use computers, satellites, and sophisticated sensors. Yet the fundamental idea remains unchanged. A submarine is a vessel that allows humans to enter a world that was never designed for us. It represents engineering, imagination, and the desire to explore what lies beyond our reach. From the quiet rivers where the earliest experiments took place to the deepest oceans on Earth, the submarine's journey has been one of constant innovation. It has been a weapon, a scientific tool, a place of discovery, a home for generations of sailors, and a symbol of humanity's determination to explore the unknown. But even after centuries of progress, the ocean still holds countless mysteries. The next chapter of submarine history may not be written only by military engineers or naval commanders. It may be written by scientists, explorers, and dreamers who continue looking beneath the surface. Because beneath the waves, there is always something waiting to be discovered. For centuries, the submarine has represented one of humanity's greatest ambitions: the desire to explore the unknown, the courage to enter places where humans were never meant to go, the imagination to create machines capable of carrying us into another world. When the first inventors dreamed of traveling beneath the surface, their ideas seemed almost impossible. A wooden vessel disappearing underwater for a few minutes was considered a remarkable achievement. Today, submarines can travel thousands of miles beneath the ocean. They can remain hidden for months. They can explore the deepest parts of the planet. They can carry humans and machines into environments that were once beyond imagination. But even after centuries of progress, the story of submarines is far from complete. The future of underwater exploration will continue to be shaped by new technology, new discoveries, and new questions about humanity's relationship with the ocean. One of the most important changes in the future of submarines will likely come from automation. For much of submarine history, humans had to be physically inside the vessel for it to operate. Crews endured difficult conditions because their presence was necessary to control the machine. But modern technology has created another possibility: unmanned underwater vehicles. These robotic explorers can travel into environments that may be too dangerous, too deep, or too remote for humans. They can spend long periods collecting information while carrying cameras, sensors, and scientific equipment. Unlike human crews, these vehicles do not need air, food, or comfortable living spaces. They can focus entirely on the mission. As technology improves, these underwater robots will likely become even more capable. They may explore parts of the ocean that remain completely unknown. They may help discover new species. They may monitor changes in marine environments. They may reveal secrets hidden beneath the waves for millions of years. Another important area of development is environmental research. The ocean plays a critical role in the health of the entire planet. It influences weather, climate, and ecosystems around the world. Submarines and underwater vehicles allow scientists to study these changes directly. They can measure ocean temperatures. They can observe disappearing habitats. They can investigate the effects of pollution and changing conditions. The same vessels that once focused primarily on military missions are increasingly becoming tools for understanding and protecting the planet. The future may also bring new approaches to submarine energy. Nuclear power has allowed submarines to remain underwater for extraordinary lengths of time, but engineers continue exploring alternatives for smaller research vessels and autonomous vehicles. Improved batteries, advanced materials, and new energy systems could allow underwater vehicles to travel farther and operate more efficiently. The goal remains the same as it has always been: more endurance, more reliability, more exploration. Another fascinating possibility is the expansion of underwater habitats. For most of history, humans have lived almost entirely on land. But submarines have shown that people can survive in completely different environments when technology provides the necessary support. Some scientists and engineers have imagined permanent underwater research stations where people could study the ocean for extended periods. These habitats could function like small underwater communities. Researchers could observe marine ecosystems directly. They could study geology, biology, and ocean chemistry from a unique perspective. While permanent underwater cities remain mostly a dream, the idea reflects the same curiosity that inspired the earliest submarine inventors: a desire to live, explore, and understand new environments. The future of military submarines will also continue to evolve. Modern naval powers are investing in quieter vessels, improved sensors, and advanced computer systems. Artificial intelligence may help submarines analyze information more quickly and make decisions more efficiently. Future submarines may rely even more on automation while still requiring skilled crews to guide important missions. The balance between humans and machines will likely define the next generation of underwater technology. Yet beyond military applications and scientific discoveries, there is something deeper about the submarine's enduring appeal. The submarine captures the human imagination because it represents mystery. The ocean is one of the last great unknown places on Earth. Even after centuries of exploration, we have mapped only a small portion of the deep sea in detail. There are still places where no human has ever traveled. There are creatures we have never seen. There are landscapes hidden beneath thousands of feet of water. The submarine gives us a way to reach those places. It allows us to enter darkness and return with knowledge. Looking back across the history of submarines, the journey is remarkable. It began with simple ideas drawn by inventors who wondered if humans could travel beneath the surface. It continued through wooden vessels, hand-powered experiments, and dangerous military prototypes. It passed through the age of diesel engines and world wars. It entered the nuclear era, where submarines became some of the most advanced machines ever built. And it continues today with robotic explorers and scientific missions. Every generation has added something new. Every inventor has contributed another piece to the puzzle. The submarine is a reminder that progress rarely happens all at once. It happens through patience, through experimentation, through failure and improvement, through people willing to imagine something that does not yet exist. Perhaps that is the greatest lesson from the history of submarines. The ocean may be vast and mysterious, but curiosity has always pushed humanity forward. We look beyond the horizon. We reach into the unknown. We build machines that allow us to explore places that once seemed impossible. The submarine is more than a vessel. It is a symbol of discovery, It represents the quiet determination to understand the world beneath the waves. And as long as there are mysteries hidden in the depths of the ocean, humanity will continue searching. The story of submarines is not ending. It is simply entering its next chapter. Throughout history, certain inventions have changed the way humans understand the world. The wheel transformed travel. The airplane transformed our relationship with the sky. The telescope revealed the universe beyond our planet. And the submarine transformed our understanding of the ocean. For centuries, the depths beneath the waves represented one of Earth's greatest mysteries. The ocean was vast, powerful, and largely inaccessible. Humans could cross its surface, but the hidden world below remained almost untouched. The submarine changed that forever. It gave humanity a way to enter the unknown. It allowed people to explore darkness, survive incredible pressure, and discover a world that had always existed just beyond reach. The legacy of the submarine is not only found in the machines themselves. It can be found in the countless ways these vessels have changed science, exploration, and human imagination. The story of the submarine began with curiosity. Long before modern engineering made underwater travel practical, people wondered whether humans could explore beneath the surface. Inventors imagined strange vessels that could descend into rivers, lakes, and oceans. Many of these early attempts failed. Some were too fragile. Some lacked power. Some could not provide enough air for their crews. But every failure taught something new. Every experiment brought humanity closer to understanding the challenges of underwater travel. The earliest submarine pioneers did not have modern computers or advanced materials. They worked with limited knowledge and simple tools. Yet their imagination created the foundation for everything that followed. The submarine's history is a reminder that innovation often begins with a question. What if? What if humans could travel beneath the waves? What if the ocean could become a place of exploration rather than a barrier? What if a machine could carry us somewhere we had never been? Those questions eventually led to reality. As submarines developed, they became powerful symbols of technological progress. During times of war, they demonstrated how innovation could transform conflict. The vessels that once seemed impossible became important strategic tools capable of changing naval warfare. The submarine introduced a new kind of battlefield. Not above the water, not on the shore, but beneath the surface. World War I and World War II showed the world the influence submarines could have. They disrupted supply lines, challenged powerful navies, and forced nations to develop entirely new methods of defense. The ocean was no longer simply a highway for ships. It had become a hidden battlefield. But the history of submarines is not only a story of war. Some of their greatest achievements have come through peaceful exploration. Submarines have allowed scientists to study parts of Earth that were once completely unknown. They have revealed deep-sea ecosystems. They have discovered underwater landscapes. They have helped researchers understand the complex systems that shape our planet. The ocean floor, once imagined as an empty and lifeless place, has been shown to contain incredible diversity. Submarines helped reveal that the deep sea is filled with movement, energy, and life. They have expanded our understanding of what environments can support living organisms. They have even influenced the way scientists think about the possibility of life beyond Earth. If life can survive in the extreme conditions of Earth's deepest oceans, perhaps other worlds may also contain hidden environments capable of supporting life. The submarine has also changed the people who operate them. Submariners have always shared a unique experience. They enter a world separated from the surface. They rely completely on their training, their equipment, and one another. Life inside a submarine requires trust. Every person aboard has a role. Every decision matters. Every system must function correctly. This creates a powerful sense of teamwork that has become one of the defining traditions of submarine service. For many sailors, the submarine becomes more than a workplace. It becomes a community, a home beneath the waves, a place where people share experiences that few others will ever understand. The submarine has also inspired countless stories, films, and works of imagination. People are fascinated by these vessels because they combine technology with mystery. A submarine can disappear beneath the surface and enter a world hidden from ordinary view. It represents adventure. It represents exploration. It represents the unknown. Perhaps this is why submarines continue to capture human imagination even after centuries of development. They remind us that there are still places left to discover. The ocean remains one of the final frontiers on Earth. Even with modern technology, much of the deep sea remains unexplored. There are still unknown creatures, unmapped landscapes, and unanswered questions waiting beneath the waves. The submarine will continue to play a role in answering those questions. Future vessels may explore deeper, travel farther, and operate with greater independence than ever before. They may help us understand climate change, discover new resources, and reveal parts of the planet that remain hidden. But no matter how advanced submarines become, their purpose will remain connected to the same dream that inspired their earliest creators: to explore, to discover, to go where humans have never been. The history of submarines is a story of imagination becoming reality, a story of inventors who refused to accept limits, a story of sailors who entered dangerous environments with courage, a story of scientists who searched for knowledge beneath the surface. From the first fragile experiments to today's advanced underwater vessels, submarines represent one of humanity's greatest achievements. They have carried us into darkness and returned with discoveries. They have shown us that the unknown is not something to fear. It is something to explore. And beneath the endless surface of the ocean, the submarine continues its quiet journey. Still searching, still discovering, still carrying humanity deeper into the mysteries of the world below. The story of the submarine is a story of humanity reaching into the unknown. It is a story that began with a simple question: could people travel beneath the surface of the ocean? For centuries, the answer seemed impossible. The ocean was too powerful. The pressure was too great. The darkness was too complete. The depths belonged to a world that humans could only imagine. But curiosity has always pushed humanity forward. Generation after generation, inventors, engineers, sailors, and explorers continued searching for a way to enter that hidden world. Their journey was not easy. Many designs failed. Many experiments ended in disappointment. Some pioneers risked their lives pursuing ideas that others believed could never work. Yet every attempt brought new knowledge. Every failure revealed another lesson. Slowly, the impossible became possible. The first submarines were fragile machines built with limited technology. They were small, uncomfortable, and dangerous. Their crews entered the water knowing that even a minor mistake could become a disaster. But those early vessels represented something much larger than their size. They represented imagination. They represented the belief that there were still places left for humans to explore. Over time, submarines evolved. Wood became steel. Hand power became engines. Simple instruments became advanced computers. Small experimental vessels became enormous machines capable of traveling across entire oceans. The submarine became one of the greatest examples of human engineering. It learned how to move through an environment completely different from our own. Above the surface, humans rely on air, sunlight, and open space. Below the waves, submarines created their own world. Inside these vessels, crews lived surrounded by machinery and darkness. They depended on one another and trusted the technology that carried them. A submarine was never just a machine. It was a home, a workplace, a place where people experienced something few others ever would. 4 generations of submariners, the ocean became a second world. They learned the language of their vessels. They understood the sounds of pumps, engines, and equipment. They could recognize when something was operating normally and when something needed attention. Their relationship with a submarine became one of cooperation between humans and technology. The history of submarines also reflects the changing nature of warfare. During times of conflict, submarines introduced a new way of fighting. They showed that size was not always the most important advantage. A small vessel hidden beneath the waves could challenge enormous ships and force powerful navies to rethink their strategies. Submarines changed naval warfare forever. They created a battlefield where silence and patience were just as important as strength. But perhaps the most meaningful legacy of submarines is not found in war. It is found in discovery. Submarines revealed that the ocean was not an empty space between continents. It was a world of its own, a world filled with mountains, valleys, volcanoes, and incredible forms of life. They allowed scientists to study places that had never been seen before. They helped us understand the planet beneath our feet and beneath our oceans. They reminded us that even on our own world, mysteries still remain. The submarine also changed the way we think about exploration. For much of history, exploration meant looking outward. People crossed continents. They sailed across oceans. Eventually, they traveled into space. But submarines showed that exploration does not always require leaving Earth. Sometimes, the greatest unknowns are found below us. The deepest ocean trenches remain among the least explored places on the planet. Thousands of feet beneath the surface, there are environments where sunlight never reaches and where life has adapted in remarkable ways. Submarines and underwater vehicles continue helping humanity understand these hidden places. They carry cameras into darkness. They collect information from impossible environments. They bring back knowledge that changes how we see our world. And the journey is far from complete. Future submarines may travel deeper than ever before. They may help monitor the health of the oceans. They may discover new species. They may support scientific missions that we cannot yet imagine. The technology will continue changing. The materials will improve. The machines will become more capable. But the purpose will remain the same: to explore, to discover, to understand. Looking back at the entire history of the submarine, one thing becomes clear. Progress does not happen because people know exactly what will work. It happens because people are willing to try. The first inventors did not know where their ideas would lead. They could not imagine nuclear-powered vessels traveling beneath polar ice. They could not imagine submarines carrying advanced technology across the world's oceans. They could not imagine machines reaching the deepest places on Earth. They simply believed that the unknown was worth exploring. That belief carried the submarine from a dream into reality. From the first underwater experiments to the advanced vessels of today, the submarine has always represented a connection between imagination and discovery. It has carried soldiers and scientists. It has explored battlefields and mysteries. It has revealed hidden worlds and expanded human knowledge. For centuries, the ocean remained a boundary. The submarine transformed it into a doorway to discovery, a doorway to adventure, a doorway into the unknown. And as long as there are mysteries beneath the waves, the submarine will continue its quiet journey. Deep below the surface, far from the noise of the world above, these remarkable vessels will continue exploring the oceans that cover our planet. Because the story of the submarine is ultimately the story of humanity itself. A story of curiosity, a story of courage, a story of the endless desire to see what lies beyond the horizon, even when that horizon is hidden beneath the waves. As the ocean grows quiet and the world above the waves begins to rest, beneath the surface another world continues to move. Deep below the horizon, where sunlight fades and the pressure of the ocean surrounds everything, submarines continue their silent journeys. They travel through darkness. They explore hidden places. They carry humans farther into the unknown than many generations ever imagined possible. The story of the submarine is not simply a story of machines. It is a story of curiosity. It is a story of imagination. It is a story of people who looked at the vastness of the ocean and wondered what might exist beneath its surface. For thousands of years, the sea represented both opportunity and mystery. Humans could cross it, sail upon it, and depend on it, but the world below remained almost completely hidden. The depths belonged to another realm. Then came the first dreams of underwater exploration. Inventors created strange vessels that seemed impossible. They experimented with wooden chambers, hand-powered mechanisms, and fragile designs that could barely survive beneath the waves. Many of these early attempts failed. But failure was part of the journey. Each mistake revealed something new. Each experiment brought humanity closer to understanding the challenges of the deep. Eventually, those dreams became reality. Submarines grew stronger. They became faster. They became more reliable. The vessels that once struggled to remain underwater for a few minutes eventually became machines capable of traveling across oceans and staying hidden beneath the waves for months. They changed warfare. They changed exploration. They changed our understanding of the planet. During times of conflict, submarines demonstrated the power of patience and secrecy. They proved that a vessel did not need to be the largest or most powerful to have a major impact. A submarine's greatest strength was its ability to disappear, to wait, to move silently through a world where few could follow. But beyond warfare, submarines also became symbols of discovery. They carried scientists into places that had never been seen by human eyes. They revealed deep ocean ecosystems, underwater mountains, and landscapes hidden beneath thousands of feet of water. They showed us that our own planet still held mysteries. Even today, the ocean remains one of Earth's final frontiers. There are places deeper than the tallest mountains are high. There are creatures that survive in conditions once thought impossible. There are entire environments waiting to be understood. And submarines continue helping humanity uncover these secrets. Perhaps the most remarkable part of the submarine's history is not the technology itself. It is the people behind it. The inventors who imagined what others could not. The engineers who solved problems that seemed impossible. The sailors who entered a world of darkness and trusted the machines around them. The scientists who searched for knowledge beneath the waves. Every submarine carries the work, dedication, and curiosity of countless people who came before. A submarine is a reminder that progress often begins with a simple question. What if? What if humans could travel beneath the ocean? What if we could explore places hidden from sunlight? What if the unknown was not something to fear, but something to understand? Those questions transformed the world. They turned impossible ideas into reality. And they continue inspiring future generations to explore further. From the earliest underwater experiments to today's advanced nuclear-powered vessels and robotic explorers, the submarine represents humanity's endless desire to discover. It reminds us that there will always be new places to explore, new mysteries to solve, new horizons waiting beyond our reach. The ocean is vast. The darkness beneath the waves is immense. But throughout history, humans have always found a way to venture into the unknown. The submarine is one of the greatest examples of that determination. It is a vessel built from imagination, powered by science, guided by curiosity, and carried forward by the belief that there is always something more to discover. So as this journey through the history of submarines comes to an end, imagine the quiet world beneath the surface, the gentle movement of water passing over steel, the soft glow of instruments inside a control room, the steady rhythm of a vessel traveling through the deep. Above, the waves continue to roll beneath the stars. Below, the submarine continues its endless voyage. Still exploring, still discovering, still searching the hidden depths of our remarkable planet. And somewhere in the darkness of the ocean, the next chapter of submarine history is already waiting. Good night.